for doing this. So just to type Falsatad circuit simulator. So if you type means so the first website is the correct website, that is a Falsatad circuit simulator. Just to open that. So if you open that website means it's look like this only. This is the user interface for the Falsatad circuit simulator. So already there is some circuit will be there. So first of all we have to clear this circuit. So for that you just go to circuit and there is an option called blank circuit. Just to click it. If you click it means so the entire circuit will be gone. And now this is the place for us for creating the circuit. So for today, I'm going to create all the combinational logic circuit. And for the example point of view, I'm going to create half order and the remaining combinational logic circuit, I'm going to show you the output alone. So let me start. So first I'm going to design a half order. So for half order, we require two gates, that is a exclusive R and exclusive R and AND gate. Actually, half order having two inputs, that is A and B is the inputs and sum and carry is the output. So we need two gates, so two inputs and two outputs, right? So first of all, we have to take the gates from the simulator. So for that, just in the black color window, you just drag your mouse and make a right click, and in that there is an option called you can see logic gates input and output. So it is there, no? So from that you have to select first we need XOR gate, so exclusive OR. So if you choose, and that means your mouse pointer will be changed to plus symbol. Just in that, just click it and drag it means the whatever the gate we choose, so that will be appear in this window, right? So the first gate is chosen, and one more gate is required to design the half order. So the next gate is AND gate. So again the same procedure, just to make a right click, and in that there is a option called logic gates input and output. So from that there is a point and add AND gate, just to choose it, and again just to make a click, that is a left click and drag it means so you have the OR gate IC. So now the gates are created. Okay, so now we have to assign the inputs and outputs. Okay, so for that again you have to make a right click, and then there is a concept called input and sources. One second. Okay, sorry. So again make a right click, and in that logic gates, so since we are doing digital based circuits, we are going to use only this pamphlet, that is logic gate. So in that there is an option called add logic input. Just to click it, and from this we have to create the inputs. See, like this you have to create the input. So we need only two inputs, so and we need two more outputs required. So for that again make a right click and go to add logic output. So here one output will be there, and here one more output will be there. So next we have to make the connections. So connections for the circuit. So what is the connection for the circuit now? So again from the input 1 we have to join the AND gate input 1, and for the input 2 we have to join the AND gate input 2. So for that again make a right click. One second. There is an option called add wire. You can see. So in the top there is an option called add wire. Just to click it, and from that you have to so first input is connected, and the next input, so next input also connected. Okay, so now the connection is over, that is both inputs and outputs are connected. Now if you want to change the input and output mean, there is an option. If you want to change the input and output mean, there is an option. So for that just to make a right click, and in that there is an option called output and label. So in that there is an option called add text, so you have to give that. So if you click means it is showing hello. So after that we have to edit it. So then we'll do it later. Okay. So if you want to edit the hello word means just in that hello word, if you place your mouse cursor and make a double click means, so one pop-up window will appear. So in that you have to change the inputs. So I am just replacing the hello to A input. So likewise here I am just replacing the hello input to B, and then here sum, and here I am going to change as a carry, right? And also if you want to mention your name as well as if you want to mention the uh, circuit diagram means, so the same procedure only. See here I'm going to change it to my name, that is Dr. M Shakti Mohan KIT. Okay, and in that I'm going to change into the design diagram, that is a half order. So now our circuit is ready. So now the next part is we have to give the inputs and check whether the output is coming or not. Will do, right? Okay. So here there is a concept L means low, that is 0. If it is H means it stands for high, that is logic 1. Okay. So now so there is a button here, run button will be there. So just to click that. Okay. So I hope you know the truth table for the half order. That is, if you provide 0 and 0 means it will give sum also 0, carry also 0. So likewise, if you provide, let me check. So 0, 0, I'm just given. So the sum also 0, carry also 0. So now I'm going to change to the B input, that is 0 and 1. If I change that L into H means, that is 0 to 1 means, now you can see the sum having the result of 1 and the carry having the result of 0. So the half orders output, the half orders truth table. And then again we have to change the input, that is 1 and 0. Again 1 and 0 means sum is equal to 1 and carry is equal to 0. And the final input, so both will be 1. That is A also, say A is equal to 1 and B is equal to 1 means, I hope you know. So if you provide 1 and 1 in the half order, it will give 10. So 10 means 0 stands for sum and 1 stands for carry. So that is what here you can see. Okay, so this is how you have to design the circuit with the help of Falsatad simulator. Here I'm just designing the circuit for half order. So likewise, I already designed some basic circuits. I'll show you one by one. So there is an option. If you want to save this file now, there is an option called save as. Okay, if you want to save this now, so for the future references you can use that file. So now I'm going to show you the next cycle. So I already completed. So open file. It is there here. I'll show you. Yeah, first I'll show you the full order. Yeah, you can see this is what the full order. I hope you know the truth table for the full order. So again, if you want to, these are the inputs. 0 0 0 means sum 0, carry 0, and 1 1 means sum is equal to sum is equal to 0 and carry is equal to 1. Actually the first output is carry and the second output is sum. And if you change into 1 1 1 means, so both will be 1, that is sum also 1 and carry also 1. So this is the circuit design for the full order. So likewise I'll show you one more circuit. You can see. So magnitude comparator. So this is what the magnitude comparator. I hope you know the concept of magnitude comparator. So let me brief it one more time. So magnitude comparator means it is a combinational logic circuit which is used to compare the magnitudes of the numbers. So magnitude means the weight of the numbers. So the highest priority is 1 1. So next is 1 0 and next is 0 1 and next is the 0 0. For example, if A is 1 1 and B is 0 1 means, so A is greater than B. So that means A greater than B la we have the output of 1 and A less than B and A equal to B la we have the output of 0. So likewise the circuit will behave. So now we can see the inputs are 0 0 and 0 0. So that means you can see A equal to B alone having the high input means, So both the inputs are same. So that is why A equal to B is high and the remaining two output, that is A less than B and A greater than B, is low. Okay, now if I change means you can see, so if I change this input, that is 0 1 and 0 0, if you provide 0 1 and 0 0, now what is the concept now? So A value is greater than B. So now you can see A equal to B is equal to 0 and A less than B is equal to 0, A greater than B is equal to 1. So just like that it behaves. For example, if I change this B is greater than what has happened, you can see. So now the input is A is 0 1 and B is 1 1. Now you can see the output, that is A equal to B is equal to 0 and A greater than B also 0. So A less than B is high, that is 1. Okay, so just like that this circuit will behave. So I'll show you one more last circuit, that is 7-segment decoder. Okay, so this is what the 7-segment decoder circuit. I hope you know the concept of decoder circuit. The concept of decoder is n is to 2 power n. That is, we have a n number of inputs and 2 power n number of outputs. That is what the concept of decoder. That is, it is the opposite of encoder. So here I am just designing the 7-segment decoder. That is, in the input side, whatever the binary code we are going to give, so that will be displayed in the 7-segment display. For example, now you can see, let me change into 0 0 0 0. So that means the actual digit for the 0 0 0 0 is equal to 0. So you can see the 7-segment display indicates 0. Now you can see if I change into 1 it will display 1. Now you can see if I change it to 3 it will display 3. So likewise it is showing the entire binary digits. But remember one thing, it is showing the hexadecimal value only. That means after 9 it is having the alphabets, that is for 10 A, for 11 B, likewise for 15. So see, you can see here I am just give the input of 15. So for the respective 15 input, the 7-segment display displays F. So F means hexadecimal number of 15. So I hope you understand. So this is how you have to design. If you want, you have to design the combinational logic circuit using Falsatad simulator. So like the same, if you want to design sequential logic circuit, so there is an option in the Falsatad simulator. Okay, I hope you like this video. In case any doubt is there, please mention it in the comment so that I'll clarify your doubts. Thank you. Thank you so much.